We're going to start on lesson 5, which is talking about normal distributions. Question 6. Problem 6. Says the mean score of all GRE scores is 150.8 with a standard deviation of 8.8. Scores on the quantitative portion of GRE are approximately normally distributed with the mean and standard deviation. So it's just 150.8 and 8.8. That's easy.
Okay. What proportions of the people who take the quantitative portion of the GRE will score above 165?
So we need to score above 165. So where's your calculator at? So we need to take 165 divided by the mean, or minus the mean. And then divide that by standard deviation. Then to find the probability, we go to the app. So the proportion that will score above is 1 minus 0.9467, 0.533, is that it? Bam, that's it. 0.533.
No, 0.0533.
Yes, sorry. If a student's score is the 10th percentile, what would the corresponding z-score be? So then we go to the applicant again. You put in 0.21. So the z-score would be
1.28.
negative 1.282. What is the quantitative GRE score for a student who scores in the 10th percentile? I think for this one we have to do that, like reverse the equation.
Oh, yeah.
So 58 plus negative 1.2816 times 8.8. 139.5.
Bam.
140. Do you understand that? Make sure I do.
Backwards. The equation is flipped around.
I know, I'm just trying to make sure I can put the numbers in. Alright. You want to read this one?
Sure. The mean speed of hydrogen at room temperature is 1,800 millimeters. What is that?
Milliseconds. I don't know, meters per second.
Meters per second with a standard deviation of 600 meters per second. At room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of what? Meters per second.
1800.
1800?
Yeah. It just says that.
Like this.
Get that one move there.
And a standard deviation of 600. Why did it say it right there? Okay. What is the probability the randomly selected particle has a speed over 2,500?
So 2500 minus 18. 700. Find the probability.
Yes.
Is over 2500.
Right there.
And divide that by the standard deviation. 600. So z-score is 1.1. 1.166666666.
Oh, 6. Yeah, 6.
Okay.
Okay. What is the probability that a randomly
Wait, that's not it. That's not the answer. That's the z-score.
Oh.
That is, then we look at the top of the graph. And you minus 1 minus 0.8784. You get 0.1216. Make sense?
No.
So this is the area that is underneath that z-score.
Okay.
So in order to get the above, you can either do that by clicking that part, or if you click these two, then you put 1 minus that, because that's the area that's not shaded.
So what does that give you then?
0.1.
So what is that?
It's the probability that someone will have a randomly selected particle be over 2500.
Oh,
Makes sense?
yes.
What is the probability that a randomly selected particle has a speed that is less than 2500? That is just going to be, I think it's going to be 87, 0.8783. What is the probability that a randomly selected particle has a speed that is less than 1500? So 1500.
Minus 1800, right?
So this is negative 300. Divide that by 600. That gives us the z-score of negative 0.5. That's it. Okay, yeah. So we want less than that speed.
Yep.
I believe it's 0.30.
It is.
What is the probability that a randomly selected particle has a speed that is between 1500 and 2500? This one's a little tricky. So, okay, so this one we're going to do, what's the numbers again?
1500. 2500. So 1500 minus
1800. Let's see, we already did these numbers. Divided by 600. So we negative 0.5. Write that down, negative 0.5.
just negative 0.5.
Just write that down for now.
I did.
And write down 1.66667. 1 point. I know it's just put 1 point. I messed up.
6667.
Yeah. Okay, so those are the z-scores. So back to this. So, 2.922. Okay, so 0.8783 minus 0.3085, 0.5698 is what the probability is. So for this one, the probability is 0.5698.
Okay, how do you find that?
So you go back and you get the areas of each of these. So you type in 1 z-score, then at the bottom which is 1.167,
Okay.
and you get the area of 0.874, and then you type in 0.5, get the area, which is 0.3085. You subtract this from point,
Yeah.
that's what you get. What is the third quartile of the speeds of hydrogen at the room temperatures? During your group presentation meeting, you will determine whether the data is this as F a different question than yes it is. So we need to find the 75th percentile on this one. So remember to do
Oh, that's really messed up.
remember to do this percentiles.
No, no.
Oh, yeah.
The percentiles.
Type 0.75 on the top of that graph. So standard deviation. No, excuse me, no. So the mean. Remember, we're solving for x.
Right.
So 1800. So we flip that over.
Plus that z.
Times by
600, and the 600 is that standard deviation.
2,204.4. So we need to find that it is normally distributed or not.
In what one?
In all 6 of these. I think the more linear it is, if I don't write that, I can tell it's normally distributed. If the data follows a normal distribution, then we expect these lines to follow a straight line. Okay, so let's look at number 1. Do you think that's normal or not? Does it follow a straight line?
No.
So it's not. Okay. Plot 2, or B. Do you think that's normally distributed?
No.
I don't think so either. It's kind of wavy. So C, that one's pretty close.
Yeah. Thanks.
Or 2.
Same with B.
Yep. Okay. I think those are both pretty close. What do you think about E?
I don't think E is. It looks pretty close, but I don't think.
You think that little curve? Yeah, I guess you're right. If
But F is.
yes. You ready to take the test? You ready to take the quiz?
Did you turn your thing on?
No, take it on there.
Oh, the group quiz. Okay, ready? Okay. The total area under a density curve must equal.
Is it 100? It's 1. It's 1.
Under certain circumstances, a density curve can drop below the x-axis.
I think that's false.
Yeah, you too. The normal density curve is symmetric.
So I know what it is.
Yeah. Use the following image to answer questions 6 through 7. Which of the following elements of the figure represent the z-score of this image?
C.
Which of the following of the elements of this figure represent the probability that a random variable z will be greater than 1.000?
Which the following elements of the figure represent the probability that the random variable z will be greater than 1. I think it's B, isn't it? Yeah, it's
Yeah.
B. According to the 68, 95, 99.7 rule, what proportion of the data on a bell-shaped curve distribution will be within 1 standard deviation of the mean? 68. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Leave your answers in the decimal accurate to 3 decimal places. If the answer was 0.3, yeah, you enter 0.3. Suppose. What proportion of the values from this random variable will be between -1? That doesn't quite make sense to me.
So I think it's looking for this number, isn't it? Yeah, can you just say that?
0.589? I was asking. 0.1589?
Yeah. 1.589. Wait, why 9?
Because you got to round it. Oh, excuse me. 1.159.
1.159, yeah. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2? So it's asking the same thing.
Like this. 0.955. Suppose random variable z has a standard normal distribution. Use a normal applet. So
It's asking the same thing.
3.997. Pretty much following that. Look carefully at your answers to the last 3 questions. What do you observe? The values match the 60.
Yeah, that's what you were just about to say.
So, did we do this one wrong?
The first one?
Yeah. Yes.
Yeah, we did.
0.683. We're looking at the wrong sheet and stuff. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed. In the population of the United States, the protein requirement is given in terms of the numbers of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirements for adults is 0.66 grams protein, yeah. And the population standard deviation is 0.07. Use this information to answer questions 14 through 17. What proportion of the population have a protein requirement that is less than 0.6? So the mean is 0.66. So then 6 minus. So at 0.06, divide that by 0.07.
Where'd you get 0.06?
Because we're looking for something that is less.
Oh, well, wouldn't it be 0.60?
0.60 minus the mean.
Right, you said 0.06. That's why I'm questioning. You know what I'm saying?
No.
You just keep
0.6 minus 0.66 is negative.
You just said, oh, okay.
Divided by 0.07 is negative 0.857. And that's the z-score, isn't it? So 0.196. So the same thing is more
It's
than
more than
0.8043. So don't have all that in though.
it's just 804.
0.804, yeah. Less than 7. 7 minus 0.66. 571. .284.
To find the area between two values, you can subtract the area to the left of each of them. Make sure your answer is positive. This is the probability that a random selected observation will lie between two values. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. Give your answer as a decimal.
So for this, I'm bleeding. So looking to the left. That confuses me a little bit.
Yeah, I'm confused too. Wouldn't it?
Okay, got it. So we take the probability that's less than point. So hold on. Okay. That seems like a small number though. 0.088.
I think that's right, though. That's what I was going to say to do.
But think about it though. This is between 0.6 and 0.7, and the mean is 0.66. So how could it just be 0.088? Did we do something wrong?
I think that's what I remember.
It's not right. Something's off.
That's right.
Or is it that?
You know, maybe it is that because that's what we got closer to this. Wait, that is that.
No.
So what do you get if it's that one? That's what you get.
So what did you do?
I took this number and put it here, so you take that minus that.
I think we fixed other things too then. So we put 8
804.
one there. That's not gonna make sense. But actually it might. Put 0.196 there. Ooh.
Do we get the same thing? That's weird. Why did we get the same thing?
It's pretty good.
Is that what you say?
That one makes sense.
The first one.
Yes. There we go.
Okay, 5.2. That's better.
I think that should be it.
That I agree with you because that just yeah.
All right, feel good about it?
Yeah. Oh no way, man. Way to be so smart. Wait, what? What the heck?
You do not put 0.520.
I did. 520.
Yes.
That's dyslexic. Dang it. Come on. Way to go.
That's it.